All right, guys, good afternoon. We are continuing our work on naming organic structures as well as drawing organic structures. So we have one naming that we're going to look at today. And first we find the longest carbon chain that includes the extra thing that will make a difference in the parent name. So I agree, some of you are looking at this and say, well, that's a methyl, that's an ethyl. But before you can determine that those are methyl and ethyl, you have to see if they're part of the longest carbon chain or if they truly are alkyl groups. We know that this is an alkene and it must be part of the longest carbon chain. So we will start here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. So it looks like 5 is the longest chain. It is easiest to just simply say 1, 2, 3, 4, 5. So we will circle this as the longest carbon chain, which then does make this the methyl group, and this is an ethyl group. If I had wanted, I could have gone up and made the bend. This would have been an ethyl at that point then, and this would have been the parent chain. It is obvious, though, to me, it's easier to see it when it's in a straight chain. This is an alkene, and it's a 1, 2, 3, 4, 5 carbon alkene, so that makes it pentene. We will have to number where the double bond is, so we have to number 1, 2, 3, 4, 5. We number in left to right direction because we want the alkene to have the lowest number. I agree with you that if we numbered 1, 2, 3, this would still be 3, so it makes no difference 1, 2, 3. So in both directions they get to be 3. Had this been one carbon closer and been on the 4, we still would have numbered it left to right because we want the alkene to have the lowest number because it is the important functional group that changes the name of the ending of the compound. Functional groups are more important than alkyl groups when we number the carbons. So let's go to the naming. Eth becomes the first thing that will be written because E comes before M. So it's on the third carbon, so we will put 3-ethyl dash 3-methyl dash 1-pentene. So let's go back through that again. Ethyl is on the third carbon, methyl is on the third carbon. The double bond starts between the first and the second carbon, so that's why it's called 1, and it's pentene because there are 5 total carbons. It has the -ene ending because it's an alkene. I find that drawing structures is much easier, so let's try this. We're going to start at the end. Butane, let's dissect that. That means 4 carbons, and this means a triple bond. Where is the triple bond? It's on the first carbon. So let's put 4 carbons. So 1, 2, 3, 4. We will put the triple bond, not double, triple bond because of the 1-butane. So if we filled in our hydrogens here, this would be simply 1-butane. So this is carbon 1, 2, 3, and on 3 we have 2 methyl groups. So we put our 2 methyl groups. So this is 3, 3 dimethyl. This is 1-butane. Let's add our hydrogens. Notice now on this carbon you have 4 bonds already. Here you have 3. You just simply need 1 more hydrogen. And this hydrogen could have gone anywhere. If we were to draw this, let's go back actually, if we were to draw this as a line structure, it would be 1, 2, 3, 1, 2, 3, 4. Our triple bond here, triple bond there. So 1, 2, 3, there's our triple bond. Here's 1, 2, 3, and we could just simply do that because this would be a methyl and that would be a methyl. So kind of crazy looking. I draw those a little small, so should have drawn bigger. Looking at propene, we have an incorrect, no we don't. I started to say we had an incorrect name. I thought we probably needed to number where we put the double bond for propene, but I am incorrect. We don't need to because there are only 3 carbons. So no matter how you look at it, it's 1 propene. So we don't put a number when it's 1. So let me explain this. Propene means 3 carbons, 1, 2, 3. And because this is propene, and there are only 3 carbons, it makes no difference where I put the double bond, because if I put the double bond here, it would be 1 propene. If I put the double bond here, it would also be 1 propene. So there's no reason to put a 1 propene. I'm going to make it visually easier for me and put it on this side on the left. So if I filled in the carbons as I have filled in the hydrogens, this would simply be propene. Where is the methyl group? This is the first carbon, this is the second carbon. I'm going to put on a methyl group. So there's my methyl group, so this would be 2-methylpropene. On the third carbon, I have an iodine. So I put in my iodine. If I wanted to go on and put on lone pairs, I could. I haven't been doing that on the rest of the compounds. It is fine if you do it. It's okay for me right now if you don't. Notice we now have 4 bonds around carbon. We have 1, 2, 3, 4 around this carbon. We need 2 more, so we fill it in with the hydrogen. If we were to draw this, this would be the line structure for propene. This would be propene as I've drawn it. So 1, 2, put on a methyl, put on an iodine. And we do have to put the heteroatoms that are not carbon or hydrogen. 2 more to do. Go backwards on this one, butane. That's 1, 2, 3, 4. That would be butane. 3, 3 dimethyl. 1, 2, 3. Put methyls. So if I were to fill in all the hydrogens at this point, this would be 3, 3 dimethyl. On the first carbon, we actually have 2 bromines. So I'm going to do a bromine and a bromine. Again, I can put in lone pairs if I choose. I'm not going to do that this time. Fill in my hydrogens. So looking at this again, let's make sure we know what we're doing. 1, 1 dibromo. This is the second carbon, nothing is on it. This is the third carbon, and it contains 2 methyls. I've got a total of 4 carbons in my main chain, all single bonded, hence the ending butane. So if I were to draw the line structure, 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons on my first carbon, and I'm actually going to flip it. I'm going to call this one my first carbon now. I'm going to put a bromine and another bromine. So if this is 1, 2, 3, and I have a methyl and a methyl. So this is the same as this, but I've flipped them. They're flipped. Last one gives us the name diol. Diol means 2 OHs. That's what we're meaning when we say diol. So it says butane diol. That means 1, 2, 3, 4 carbons. And it's telling us, by putting the 1 and the 4, it's telling us where the OHs are. So we have an OH on the first carbon, second carbon, we don't have an OH, third carbon, we do not have an OH, but on the fourth carbon, we also have an OH. So if I were to stop right there, fill in all of my hydrogens, I would have 1, 4 butane diol. But we also have a methyl group on 2. So there's the methyl group on 2. We have another methyl group on 3. So we have 1,4-butane-diol, and this is 2-methyl. This is a 3-methyl, so that's where we get the dimethyl. Now fill in all of your hydrogens. Double check your bonds, and we have the right number of bonds, so let's draw the line structure for this. 1, 2, 3, 4. We have an OH and OH, and we have a methyl on 2, and we have a methyl on 3. Pretty neat looking compound. Alright, hope this helps. Watch it, and good luck on your exam.